8-4 trigonometry. You guys know what trigonometry is? Study of triangles. Okay, we're studying triangles. It's all based on right triangles. So everything we're doing today has to do with a right triangle. Okay? First thing we're going to talk about today, first of all, draw yourself a decent right triangle. A, B, C. Here's your right angle. Okay, and what we're going to go ahead and do is we're going to label each side to measure by X, Y, and Z. First thing we're going to talk about are your trig functions, which this is all based on. We're going to talk about the concept of what a trig function is. You guys, like I said, what makes this more difficult, my people have problems with this because you've never heard of it. The only time I guess you probably have heard of it, but you probably knew it as sin, cos, and tan. The three things on your scientific calculator that you had no idea what in the world they meant. Okay? We're going to talk about that now. Do we need to delve into the details of cosine, sine, the sine function, graph, all that stuff? No. Okay? We're going to talk about some basic stuff. But first, we've really got to understand what you're doing when you find sine. First of all, there is sine. Okay? You always find the sine of an angle in a right triangle. And this is how you'll see it written. You'll have sine, and in here will be your angle measure, and then equal to a number. That's how you find the sine. And there's three we're going to talk about. Sine, it's not, but it have to be written S-I-N, they won't put the E on the end. Okay, it's always sine, and this is the part that gets lost sometimes, is that it's sine of an angle equals a number. That angle is the location of what you're talking about, and it'll be so very important. We've got to understand that. You always find the sine of an angle in a right triangle. You always find the sine of an angle. Second one, cosine. I'm going to say the same thing here. You always find the cosine of an angle in a right triangle. Okay? That's always what you find. The cosine of an angle is equal to this. Okay? It's always got to be an angle measure. You'll see it kind of written. It'll be cosine, and we'll have parentheses, and inside here you'll have an angle measure. For instance, somebody give me an example of an angle measure.
60.
Cosine of 60 degrees is equal to this. And your calculator will spit out a number. We're not going to do that part today. But you can put it basically into your calculator and it would spit out a number. Make sense? But it's always cosine of an angle measure. Very important. The third one, tangent, you're always doing with a tangent? You always find the tangent of what? An angle in a right triangle. Same thing, you're finding the tangent of an angle equals this. So when you put it into your calculator, you're putting tangent of an angle measure, 30 degrees, 35 degrees, it will spit out a different number for each. You set it up and how you see it written down, you see TAN, parentheses, and inside that parentheses will go what? The angle measure. And then equal to, when you put it in your calculator, it will spit you out a number. Okay? We're not going to delve too much into saying what's the tangent of 41 degrees and you rounding it, putting in your calculator, rounding it to the nearest whatever. I mean, we will have to do that some. But we're going to talk more about how to set up proportion and set up your trig functions. So that's your concept of what sine, cosine, and tangent are. They are the relationship between an angle and a right triangle, and that'll spit you out a number. Now that relationship has some rules, and that's what we're going to talk about next. It actually has to, what we're going to do is we're going to write an angle with the measures of the sides in a right triangle. Okay? Now, you might know what that means. Sine of theta. Okay? They'll use theta to represent a measure of an angle. Okay? So it's sine of what? Some angle. Your rule for sine is always equal to opposite leg over the hypotenuse. That's what sine is always equal to. And what am I talking about? I'm talking about sine of some angle is always equal to, or with respect to that angle, the opposite leg, the measure of the opposite leg over the hypotenuse. Cosine of theta. It has a different ratio. It is always the adjacent leg over the hypotenuse. Tangent of theta is always equal to the opposite leg over the adjacent leg. I'm assuming that probably looks like a different language almost up there. It looks weird. I understand that. But you'll find that for solving these, like I said, we're not going to solve them today, we're going to set them up today. These involve finding this, if there's a number in there, it involves calculator work. Basically, it's a proportion cross multiply and solve. That's it. Okay. Well, what we're going to talk about first, though, is how we set these up and what they mean by opposite and hypotenuse. And these are the first type of problems on your worksheet that I've given you. And this gets lost a little bit. And the most important thing is, what are we always finding the sine of? Okay. We're always find a sine of an angle. So really the most important thing in here is angle. So what we're going to do is we're going to look at this picture up here. And what I want us to do is we're going to find the sine of angle A, the cosine of angle A, and the tangent of angle A. Now I know we're not going to get numbers for this, but what I want us to do is I want us to look at this and see if we can tell what that would be. So once you get that written down, or you even don't have to, I'm going to give you a second to write this down. Let's talk about this. All right, I'm standing right here. Who's the first person opposite me right now?
Sierra.
Sierra. Okay. I'm standing right here. Who's the first person opposite me? Zach. Right? I'm standing right here. Who's the first person adjacent to me? What's adjacent mean? The side, right? That would be what? Okay, what you have to understand now is that this opposite and this adjacent is always with respect to something. That all changed by where I moved, didn't it? Okay? Who's opposite you? Depending on which way you're facing, correct? Okay? So, what do you think we're going to be opposite of? What did I say was the biggest part of sine? Know that we're taking the sine of a what? So, what do you think when I say opposite leg? I'm saying opposite of what? Though? It has to be opposite of something, don't you?
A.
In this case, it's theta. If I'm finding the sine of A and I'm setting up this ratio, what? I'm opposite of what? Well, sine of what?
A.
Well, let's look up here. A is basically a location, right? You can say this like a Wasso. What side is opposite of Wasso up here?
Y.
All of you can answer that question, can't you? So you see what I mean, that it's really, in some ways, the concept of what you're doing is really pretty simple. So, and you're exactly right. Opposite A is what?
Y.
So sine of A would be Y over.
Z.
Now,
What would be
a hypotenuse, is the hypotenuse going to change any?
E.
The hypotenuse isn't with respect to anything. It's always opposite the what?
90.
The right angle. So it's over what?
Z.
So guess what the sine of A would be? Whatever value Y is over whatever value what?
Hypotenuse.
Z is. How easy is that?
So you're gonna tell us the numbers of the sides?
Yes.
One thing at a time. Cosine of A. How is this going to change? What has changed? Did what I'm saying, the function changed? But did my angle change? You have to pay attention though. Each time you can say, oh, what am I finding the adjacent to what?
A.
In this case, A. Where is A? It's right here. It's the adjacent leg. Because really, what sides are adjacent to A?
X and Z. but
X and
Z
Z.
is the
What's Z always?
hypotenuse.
In this case, Z is always the hypotenuse. So obviously, we're talking about the adjacent what?
X.
Leg. So what is adjacent?
X over.
Over the hypotenuse, which is still. How about tangent? Tangent of what? A. And it's important. You always find a tangent of an angle. So everything is always within respect to that angle. Well, according to A, the tangent to A, what is tangent? Opposite over what? Which is what? Y over what?
X.
Adjacent, which is?
X.
Is that hard?
No.
Not at all. And these are some of the easier problems. Now, with that in mind, I want to see if you guys can do this right quick. Find the sine of C, cosine of C, and the tangent of C. have the rules changed? No, what's changed? What I'm talking about in perspective to. Remember, it's always opposite something, that angle, right? In this case, y was opposite what? A. So when I find the sine of,
C, that's gonna be opposite.
and that's the other thing, and I hate this stupid part in the end, but always use the KISS principle. Because a lot of these things are like, God, is it really that simple? It is. Keep it simple, stupid. I hate the stupid part. But I mean, really, it's like, God, could it really be that simple? Yeah, it is. Hey, what's opposite C? Like I said, you guys have no problem. If I ask you right now, what side's opposite C?
X.
All of you would tell me X, wouldn't you? It's just that we put a sign in front of it, and sometimes we kind of freak out. Over, if I ask you any of you, which one's the hypotenuse? We've gotten pretty decent at that, I'd say. All of you could tell me Z, couldn't you? I put a sign in front of it or some kind of weird, it kind of freaks us out, right? But the key is understanding that we're always talking with respect to what? See how the sign was different here than it was here? Because I was talking about different what? Angles. So it's going to change, isn't it? Okay. Cosine of C? That would be the adjacent to C, which would be
Y.
over what?
Z.
Everybody okay with that?
Yes.
How about tangent to C?
X.
You guys can do that, can't you?
Yes.
All right. If you want to start if you've already written all this down, we are going to do numbers 1, 2, and 6 right quick on the board. You guys want to look and see what you would do there. It's no different than what you just did, except what? Where there was an X, there's a what now? A number. Now, if you don't start with a decimal, don't what?
And
So simplify that fraction, if it can be. Can I erase this while you guys are doing that?
Do we only have to put one thing down? We don't have to
Like I said, KISS principle. You're like, is it really that simple?
wait, so like I don't have to do the
You don't have to do you have to do exactly what it says. It
Oh,
wants
you
to
were
find-
gonna say you don't have to do nothing. I was like, I'll take that option.
No, you don't get that option. But this is about nothing, isn't it?
I feel my brain just
Hey, like I said, if I told you, hey, this spot over here, tell me what's opposite and what's beside it, or, you guys could do that, right? That's all you're basically doing. It's just that it's weird new words you've never heard of, so it screws with us a little bit. Hey, I was your age once. You think it didn't screw with me a little bit?
So would it be 40
Seems like about 100,000 years ago, but
question mark?
there was a.
No, we don't.
that's it. That's it.
Number 1 is CB9. What's this one?
40 over 41.
No, what's this?
Oh, that's a hypotenuse.
Well, what is it?
I'm really not trying to be dumb.
Huh? What's this one?
40.
Okay, what they ask us to find?
Cosine of A.
Cosine of A. Okay. Oh, before we go on to this, I did forget to talk about this.
I think that's a college name.
SOHCAHTOA. It has been used for years and years and years to help people remember their trig functions. Okay, so, if you heard, because here's the deal, what people usually remember is they usually remember that sine and cosine have the hypotenuse on the bottom, right? Where do you think people usually get confused? They can't remember is sine the opposite or is sine the what? Adjacent, right? Well, they use SOHCAHTOA because basically remember in the SO, S and O, that relates to sine and what? Opposite. And the H is what? Sine is opposite over what? Ka. What sound, how do you make a ka sound? C-A. C is going to refer to what? A is probably going to refer to what? And then you just have to remember its hypotenuse on what. So cosine T, to-a. T is going to refer to what? Tangent. O is going to refer to what?
Opposite.
And have it. Abbreviate that, can I? Okay, cosine is adjacent over hypotenuse, but it's always with respect to what? The angle we're talking about. So in this case, what angle are we talking about?
The adjacent.
A. Cosine of what? A. With respect to A, what is the side adjacent to A beside it? 40 is the adjacent leg. Then what goes on the bottom? The what? Hypotenuse, which is? Now, is that a fraction that can be reduced? You're done. As I said, you might look and say, I can really be right. That was way too simple. Hey, so there's nothing wrong with simple.
But there was no math. I don't.
Simplifying is not.
Really, very little.
I feel like
It was a language, wasn't it?
there's numbers. It's not really.
There's numbers, so we can call it math.
I don't know if I like this though. Can we
We're gonna do it whether you like it or not, so you just might keep as positive attitude as you can, right?
It's gone.
I don't mean that to be mean, I'm just saying that's how it is. That's gonna be in life lots of times. A, B, C. What's this side?
Adjacent angle.
What is it?
18.
Oh.
It's
24.
24.
And now it's 30.
Is it really?
It's not really very important right now, is it? Things, it's hard enough without getting distracted. Think, just say, okay. I don't need to know why. Tell me why later. Now, let's look at this. What do they ask me to find here? Sine of what? A again? Okay. So what's important? I can't know what it's opposite and what's until I find out which one I'm talking about. What am I talking about?
Sin A, sin
A. So
24.
I can, if it helps you, circle it. With respect to A, I need the what? Opposite and the hypotenuse. Hypotenuse is always easy. What's the hypotenuse?
30.
That's the one on bottom, isn't it?
And then
Which one's opposite A?
24.
CV.
Now, can this reduce a little bit?
Yeah.
6 will go into that 4 and 6 will go into that 5. Okay, see, there's your some math. Made the reduced fraction.
Well,
Happy, happy, joy, joy. Positive attitude. Here we go. Win the day. Number 6, did I say next?
Yeah.
Why do you think I picked number 6? First time we are exposed to Mr. Tangent. Okay, is this A or is it B? What's this?
C.
C, is this what?
B. 49.
Huh?
29. 20.
Okay, what'd they ask us to find? The tangent of what?
C.
Okay. What is tangent?
Opposite leg
Opposite
of
over
adjacent
adjacent, but
leg.
opposite what?
C.
In this case,
So it'll be 21
C.
over 20.
The opposite of that, 21 over the adjacent, which would be,
20.
that's pretty much reduced, isn't it?
Yes.
Can we do that?
Yes.
Okay. Well, everybody's probably got this written down. While I'm erasing and writing stuff up here for what we're gonna do next, do a couple of problems, and I'll tell you when I'm ready for you to start writing, okay?
We're about to work on
We're about to work on the next ones, 14 through
14.
the rest of them.
That's the part I didn't get.
Right, and that's the part we're breaking up into 2 parts. We're gonna first learn how to set them up, then tomorrow we'll talk about ourselves, okay?
So this is our assignment for today. Like, you don't
No.
have to solve this.
Just
we just gotta follow along.
wait.
That's here, what you
How did Justin do that?
Did he steal it?
No, he got it for the price, Eddie's. He did it, he mixed
Quiet,
it up.
please. Solving for missing value in trig functions. Okay, everybody, basically there's always gonna be three numbers here that you get from either the side of a right triangle You're gonna have basically, if you think about it, you have sine or cosine or tangent of an angle. This is gonna represent a number, isn't it? Everyone agree? Equal to a number over another number, right? Okay. If you were guessing, since you've had such fun taking algebra and geometry this year, what do you think they're gonna make some problems like? They're gonna have some problems where they give you a number for this. They give you a number for this, and then they say this is what?
X.
And they're gonna ask you to what? Solve. Okay? Now, then what other type of problem they give you? Instead of giving you the top one in the fraction, they, or make it the unknown, they might make the what? The bottom one the unknown, right?
And then,
That's gonna be your second type of problem. Your third type of problem, what do you think is gonna be the unknown next?
in the parentheses.
The angle, yeah, the angle. Okay? Now, what I'm saying to you is that today, and I'm not that concerned as much with you writing this down as just listening from this point on. Because we have the video to look at if you want to write it down later. You've got two parts to this problem. One, knowing how to set it up, and two, being able to solve it. For the rest of this hour, we're going to set them all up. Okay? Big thing here. The problem itself will tell you which trig function, what am I talking about when I say trig function?
The
Sine,
sine,
cosine, or
cos,
tangent to use.
Cos.
cos.
Sine, cosine, tangent. Okay? The biggest thing is figuring out, you know you're gonna have it set up something like this, right? You're gonna have a number here, you know, one of them's gonna be an unknown, right? And then you're gonna have what? Either sine, cosine, tangent here. What we're basically gonna learn is which one to put here. Okay, and what do I mean by how the problem's gonna have you, let you know? Well, give me, and don't write this down, I'm just gonna draw a bunch of pictures up here, and we're gonna talk about what it says to you. Let's say they said that was X, that was 5, and this was 32.
Well, then you gotta find the adjacent angle, don't you?
No, don't jump to conclusions. That problem, by what they gave you, told you what trig function to use. Now, what did I tell you? There's gonna be three quantities, right? The angle, what goes on top, what goes on bottom, right? It all changes according to what function you have, right? If it was sine, the thing on top here is what? Opposite of it. If it's cosine, it's what? So, what you have to do is look at what the problem gave you. Now, what is it we always find in the sine, cosine, and tangent of? What's the most important thing to find first? What did I tell you guys? The angle.
To angle.
We're finding the cosine of an angle. Which one here is the angle?
never mind.
A 32. That's your angle, isn't it? So whatever trig function we use, it's going to be a what? 32 right there. Then we're going to have something here and something here, right?
Yeah.
Well, look at what they gave you. They gave you three things. They told you what they want you to use. What did they give you with respect to this angle? The opposite. And what is this?
Hypotenuse.
So, you found the angle, you saw that they gave you the opposite and the hypotenuse. Which one did they tell you to use? Look up here. Which one has opposite and the hypotenuse?
Sin.
Sine.
Sine. Sine.
Sine.
So you know that you're going to set this up as the sine of 32 is equal to the opposite, which is what? Over the hypotenuse, which is, you set that up. We'll talk about how we solve that tomorrow. But for right now, the most important thing, and it's like anything else, if you don't know how to start, you can't, you can't finish, I can't solve it if you don't know how to set it up correctly. So you see, do you see what I'm saying, how the problem itself told you which trig function to use, didn't it? By what they gave you. Guess what? You're gonna have another one. Say they give you, x, 25, and 10. Okay, we know we're gonna have an angle every time equal to something over something, and then we're gonna have sine, cosine, or tangent right here, right? So first of all, figure out what your parentheses, what your what is? Your angle. Where it is. Your angle is right here. So this becomes 25 inside here. So, okay, with respect to that angle, what did they give you? And label it on your paper. What did they give you?
Hypotenuse and sine, so we
They gave you the hypotenuse, and what is this?
adjacent.
It's adjacent. So, which trig function are they telling you to use?
Cosine.
Cosine, because cosine has what in it? So the cosine of 25 is equal to the adjacent, which is what? Over the hypotenuse, which is?
That was too much.
Then you saw it. I'll tell you that tomorrow.
That's the surprise.
Part of the surprise. Now, they'll probably give you a problem like this too. We're gonna have three numbers, right? You're gonna have what? An angle, and then sides. The question is, what did they give you? What do I find first? My angle. With respect to that angle, what did they give me? Opposite and what? So which one over here is opposite and adjacent? So how would we set this up? Tangent of what? 22 equals over. Now they don't have to make the x the side either. In fact, the first ones you're going to do, they're not going to be.
So what is this use?
Shh, shut up. Not yet. We're rolling, okay? One thing at a time. Now, what trig function am I going to use here? They're going to give me a what?
Side of the hypotenuse.
They gave
They're going to
you,
give me an angle, which that's the first thing I always find.
so
And don't let it freak you out just because the angle is a what here?
X.
It's x, it's a variable. With respect to that angle, they gave me the what? Adjacent and the what? So what am I going to use? Cosine. So the cosine of what? Tell me. X equals what? You guys can do that, can't you? Here's what I want. For the rest of the hour, I want you to set up every single problem from 14 on. And last hour I was able to get all of them done before they left. You work up to the bell. So what we do is we set them all up. We get a hang of that where that doesn't confuse us. We get good at that. And then tomorrow, we'll grind. And then tomorrow, we'll solve all of them. Okay? Yes? No, don't worry about the first ones because those are kind of easy, right?
Yeah.
Start at 14 right now. And hey, when you do these, you know, I've left you a box there, right? Don't write it super big and take up the whole box. Because what are we going to have to do? What am I going to want you to do tomorrow? Solve it underneath it and show your work. So just up in the tops, you know, up in the top of your box, the box there, write what it is. And for those of you that might be having some problems, please raise your hand. Like number one, that question mark, what do you think I want you to use for question mark?
X.
Okay, so on number one, they've given you the what? They've given you the angles x, and they've given you the what? Opposite and what? What trig function is that?
Sine.
Sine. So we're going to say the sine of what? X equals what? 12 over 23. You're done, go on to the next one. See what I'm saying? And guess what we're doing? We're memorizing these trig functions as we do this. Okay? Give me about 5 or 6, 7, about 40 go. You can make it, can't you? I mean, if it's an emergency, it's an emergency.